All right, so 9.1, we're still going to be in the realm of solving quadratics, but we're going to learn some other methods besides factoring to solve quadratics. Factoring will also come back into play, but give you some other tools in order to solve some of these problems. So the first one is we're going to be dealing with square rooting. So a couple review questions here of finding the square root, just simplifying those. So the square root of 49, and we're going to go what multiplies or breaks down. We can do our factor tree here, and so that gives me 7 and 7. There's our pair, so the square root of 49 is 7. Again, if you don't need to do the factor tree, you don't need to, but if you do get stuck, it is helpful. Here's one. We won't see a lot of fractions, but in case we do, remember that we can rewrite this as the square root of 16 over the square root of 100, splitting it up. Square root of 16 is 4. Square root of 100 is 10, and then we can reduce that to 2 over 5. We also could have reduced that inside there. Initially, 16 over 100. 4 goes into both, and you would have got 4 over 25 there, and the full square root of that. Either way works. All right, square root of 12. 12 is now not a perfect square, so factor tree maybe is a little more helpful for some of you. So two things multiply to 12. 4 and 3, some might go 2 and 6, does not matter. 4 becomes 2 and 2. There's our pair that goes on the outside. And then we have a 3 that is left on the inside. 27 is 9 and 3. 9 breaks down to 3 and 3. There's my pair. That's what's left on the inside, so we have 3 root 3. All right, discussion. Explain why A must be non-negative to have real solutions when you find square root of A. So as we think about this, if we had the square root of, say, -4, what two numbers would you multiply together to get -4? Remember, in order to have it, they have to be the same pair. So we have 2 7s there. We have 2 2s there. We have 3 3s there. So what two numbers would you multiply that equal -4? Well, some might say -2 and 2, but those aren't the same. One of them is negative, the other is positive. So either both have to be negative, which makes the 4 positive, or they're both positive, which also makes the 4 positive. And so that does not work. So that's why it has to be non-negative to have real solutions. Okay, so does 0 have any square roots? Why or why not? Okay, so we'll discuss that one when you come back in class, have an answer to that concept. All right, let's look at some examples here. We want to solve the equation, give the answer in radical form, and then use a calculator to approximate the solution to 2 decimal places. All right, so when we're solving by square roots, which at this point you know to solve by square roots because you're told. Later on, we'll talk about some strategies of why you would do this. But right now, we're just looking at solving by square roots. So what we want to do is we want to get our squared term by itself. So in this case, we're going to divide by 3. And we get x squared equals 16. I take the square root. And so x square root, those cancel. That's why we do the square root. It's the inverse operation, just like we divided by 3 up here to cancel those out. Square root and squared are inverse operations, so that gives me x. And then over here, the square root of 16 is what most people will put is 4. Now, the issue with that is only partially correct. So let's go back to this step before we square root it. If we think about our value of x, and I need something squared to give me 16, well, when we substitute 4 in there, that does work. 4 squared is 16. But is there another number that when we square it would also give us 16? If you came up with -4, you are correct, because -4 squared is also positive 16. So when we solve by taking the square root, what we get here is we get x equals plus or minus 4, because the positive and negative version of that answer works. So our solution for this, written a little more nicely, is plus or minus 4. All right, so let's do number 8 here. Okay, so again, we want to get our squared term by itself. And so in that case, just as if we were solving, say, 4x minus 5, we're going to add 5. And we get 4x squared equals 7. Divide by 4. And we get x squared equals 7 over 4. Take the square root. And so then we get x equals plus or minus. Now rewriting it, we get the square root of 7 over the square root of 4, which square root of 4 we can simplify, so that gives us plus or minus the square root of 7 over 2, which then, using a calculator, that gives us x equals plus or minus still 1.32. Now you won't always have to do it. Oftentimes that would be an acceptable answer, but just knowing sometimes we may need to get decimals depending on the context of the problem. All right, a couple practice problems here for you to work on. So go and do those. We'll discuss those when we come back into class. All right, so here's our discussion that I alluded to earlier. So when is it best to solve by the square root? So we've had a bunch of problems previously that looked like this. And this is a simplistic one, but we factored those. Now in the square root ones, we always had something that looked like that or that. So what we see is what we're missing is this b term. So when our b in our equation is 0, there is no just x term. We may have a squared and a constant, but no middle term. That is when it's easiest to take the square root, because then we can get the x squared by itself. Here, we can't really do that because we'd have an x on the other side. If we try to do that, we would end up with something that looks like that. And so we still have an x over there, which now we have to deal with that. Taking the square root just makes this a big old mess on this side. So when is it best to solve by square root? Is when you have no middle term, your b is 0. And then why is there a plus or minus when solving by square root? As we already kind of talked about. As we kind of think about this, and I'll use a different example. Let's go with 9. Well, what squares to give us 9 is essentially what we're trying to answer. Well, 3 squared gives us 9, but so does negative 3 squared. So both of those would work. So if we had x squared equals 9, we take the square root. My x, what I would substitute in for that would be 3 and negative 3. So that's why we get plus or minus. All right. So now we want to deal with when we have terms inside a parenthesis. So solving a quadratic equation may involve isolating the parenthesis or the squared term. Of a quadratic expression on one side of the equation first. So let's look at solving. Same deal, we'll go through the process. We'll leave it in radical form and approximate. So as we look at 14, we have our squared term here. So we want to get that by itself. Well, there's nothing on the outside being multiplied. There's nothing being added, subtracted. So it is by itself. So then we can go ahead and take the square root, just like we've done in the past. And so we get x plus 5 because the square and square root just cancel out. Square root of 36 now is plus or minus 36. Now we're going to solve still because this time our x is not by itself, so I'm going to subtract 5. And now right now, even though those are like terms, we won't combine them because we have the plus or minus. So writing it out so you can see, most of you after this will, should be a 6 here. Won't have to write it out twice. You can just simplify from there, but this is a good visual. So what we really have here is we have x equals negative 5 plus 6 and x equals negative 5 minus 6. So at the top, that gives us x equals 1, and on the bottom, that gives us x equals negative 11. Okay, let's look at 13 here. So let's divide, let's look at our squared term. Is there anything outside of it? There is that 3 there. So what we want to do is go ahead and divide by that 3. That cancels out, and then we get x minus 5 squared equals 6. Now our squared term is by itself, so we can go ahead and solve. So I'm going to take square root. That gives me x minus 5 equals square root of 6 now. So 6 is 2 and 3. We don't have any pairs, so it is just the square root of 6. Do not forget your plus or minus. Now to continue to solve, we're going to add 5. And you get x equals 5 plus or minus the square root of 6. Now those aren't like terms, so then that would be our final answer. And then for our approximation, as we go 5 plus the square root of 6, we get x equals 7.45. And then x minus the square root of 6 is 2.55. All right, a couple of your turns here, so go ahead and complete 16, 17. We'll discuss those back in class. All right, 18. Now, previously, you heard me talk about real solutions. The reason we make that statement of real solutions is there is this idea of what we call imaginary solutions. So let's just go through and find our solutions for this. So again, we have our squared term, so we want to get that by itself. So there is a 2 on the outside that we want to divide by. And so then we get x minus 3 squared equals negative 16. Now we take the square root. Well, and that cancels out there, and we get x minus 3. But now we have the square root of 16, of negative 16, which, as we already saw, there's nothing that works to multiply to negative 16. So here's where imaginary numbers come in. So if I have the square root of negative 1, what that equals is our imaginary number I. So anytime you have the square root of a negative, that is our I value. So here, the way I would deal with this is, okay, I'm going to deal with my negative first. So I pull that I out. Now I have the square root of 16. We did take the square root, so that is plus or minus there. And now, what is the square root of 16? Square root of 16 is 4, so we get plus or minus 4i. Then from here, we're going to solve, so I'm going to add 3. Those are not like terms, so I get 3 plus or minus 4i, and you leave that as your answer. So that is what is an imaginary number because we have that I value in our answer. But the process was still the same. We still got our squared term by itself. We still took the square root, and then once we had that negative, we pulled that negative out from our radical as our I, making an imaginary number. Then we took the square root of 16 just like we would before, giving us that 4. Got our x by itself by adding 3. Those aren't like terms, so then we get our final answer there. All right, so a couple of your turn problems that I want you to work on. We'll again discuss those in class. Now, a word problem here. So a contractor is building a fenced-in playground at a daycare. The playground will be rectangular. With its width equal to half of its length. The total area will be 5,000 square feet. Determine how many feet of fencing the contractor will use. All right, so a little quick diagram here. So we have our rectangle, and we have our width and length. Doesn't matter which one you label what. So the width is equal to half its length. So let's call our length x, and then our width is 1/2 of that length. And then the total area is 5,000. So length times width, so we get x times 1/2 x, and that is going to equal 5,000. Multiply those two terms together, and we get 1/2 x squared equals 5,000. Now we want to solve. There is no b term, so we can solve by square roots. So I need to get my squared term by itself. So in this case, what we're going to do is we have 1/2 times that. So when you have a fraction, the easiest thing to do is multiply by the reciprocal, which is 2. So that cancels out, leaving us with x squared. 2 times 5,000 is 10,000. Take the square root of both sides, and so x equals 10,000 is 100. Now it says determine how many feet of fencing the contractor will use. So our length is 100, and then our width is half of that, so that's just going to be 50 and 50, and so we need to add all that area up. So 50 and 50 is 100. So 100 plus 100 plus 100 is 300 feet. Not squared. All right, your turn. A zookeeper is buying fencing to enclose a pen at the zoo. The pen is an isosceles triangle. So remember, an isosceles triangle, these two sides are congruent. It's already fenced in along the hypotenuse, which borders a path. The area of the pen will be 4,500 square feet. So this whole area is 4,500 feet. The zookeeper can buy fencing in whole feet only. How many feet of fencing should he buy? So then one thing that'll help us on this one is that it's a right triangle. So let me redraw. Now these are still those. We already have fence along this side, and our total area is this. So remember the formula for our area of a triangle is 1/2 base times height. Well, this is our base, this is our height. And they end up being the same. We don't know what they are, so we'll call that one x, which means this one has to be x as well. So then my area, which is 4,500, is equal to 1/2 my base times my height, which then becomes 4,500 equals 1/2 x squared. Multiply both sides by 2, and we get 9,000 equals x squared. Take the square root of both sides, and then x equals, and since this is real world context, we could break that down by just using a calculator. We get 94.87, and then you can buy whole feet only. So then what he needs is, so that is x, and then we get x again, which is that, so we just double that. But really, this is 95 feet of fence for one side, which means the other side has to be 95 as well. So we need a total of 190 feet. Hey, little discussion. How many real solutions does x squared equals negative 25 have? Okay, so have an answer for that, along with what steps would you take to solve for that problem in the essential question, 6x squared minus 54 equals 42. We'll discuss all those once we come back into class.